We will be continuing simplifying radicals, the second day of simplifying radicals. Just as a quick review, a radical is simplified if the following conditions are met. What we went over in day one, if you have no perfect square factors underneath the radical. So here's a specific example where there is a perfect square factor underneath the radical, and we do have to simplify it. Okay, there's a second way that you could determine if a radical is simplified. So if there's a radical in the denominator of a fraction, then the radical is not simplified. Somehow you'll need to get the radical out of the denominator. And then we'll take a look at an example of that. So on our example, we want to simplify 3 over or 3 divided by the square root of 2. That radical is not simplified because there is a radical in the denominator. We somehow need to get rid of the radical in the denominator, or that's also referred to as rationalizing the denominator. In the denominator, we have the square root of 2. That's what's known as an irrational number. If you took the square root of 2 on your calculator, it'll give you a decimal. It actually keeps going, and it doesn't repeat. It's what's called an irrational number. So we need to somehow get rid of the radical in the denominator, or again, that's called rationalizing the denominator. So to get rid of the radical in the denominator, for example, is the square root of 2. I can multiply both the numerator and denominator by the radical that's in the denominator. Square root of 2 over the square root of 2. Because really what we're multiplying by is 1. Anything divided by itself is 1. That doesn't change the value of the radical. It does and will get rid of the radical in the denominator, as you'll see. So in the numerator, we have 3 times the square root of 2. What we're doing is multiplying both the numerator and denominator by the square root of 2. 3 times the square root of 2 is just 3 root 2. I can't multiply this 3 and this 2 together because this 3 is outside of the radical. The 2 is underneath the radical. This is all we can do. The denominator, the square root of 2 times the square root of 2. I can multiply these 2's together because both of them are underneath the radical. So it would look like this. Square root of 2 times 2. Maybe you skip this step and then just write it as 2 times 2 is 4. The square root of 2 is, 2 times 2 is 4, so that's the same as the square root of 4. We can simplify this. The square root of 4 is just 2. So 3 square root 2 over or divided by 2. You might think that that's more complex than what we started with, but what actually happened is we got rid of the radical in the denominator, and that's what we wanted. We did what's called rationalizing the denominator. And then our next example, 8 divided by the square root of 7. So we need to get rid of the radical in the denominator. That's not simplified for sure. And in order to do that, always take a look at the denominator. In the denominator here, we have the square root of 7. So whatever radical is in the denominator, to rationalize the denominator, you multiply both the numerator and denominator by whatever the radical is in the denominator. Again, all this is really doing is multiplying by 1. In the numerator, 8 times the square root of 7 is just 8 square root 7. And in the denominator, here's what I'm going to do. Just multiply without writing it out as 7 times 7. 7 times 7 is 49. The square root of 49, since 49 is a perfect square, is 7. So 8 square root 7 over 7, that's all we can do. Okay, you can't simplify that any further. You can't try to divide this 7 by the 7 because this 7 is underneath the radical in the numerator. This 7 is outside of the radical in the denominator. And then on the next example, 3 over the square root of 3, I need to rationalize the denominator, or again, get rid of the radical in the denominator, multiply both the numerator and denominator by the square root of 3. So in the numerator, 3 square root 3 is what we end up with. And in the denominator, it's going to be the square root of 3 times 3, which is 9. And then the square root of 9 is just 3. If you understood and followed all that, great, but we can actually simplify this one step further. So we have this fraction, 3 over 3. Both this 3 and this 3 are outside of the radical, so we can simplify that. 3 goes into 3 once, and into this 3 once. So it's 1 square root 3 over 1, or you can also just write it as the square root of 3. So even though we simplify the radical by getting the radical out of the denominator, always see if you can simplify a fraction as well. Sometimes you're able to do that. On the previous examples, we couldn't simplify it. 8 over 7, no number besides 1 goes evenly into 8 and 7. Same thing here, 3 and 2. Say if this were a 6, then we'd be able to simplify that, but it's not. That's all we can do.